let's go to LeetCode 347, top K frequent element. For this question, it gives us a numbers integer array and K, and let us to find the top K frequent element. So you see, if K equals 2, we'll return size to integer array, and the return result can be in any order. So for this question, firstly, we need to, for every element, we need to use a map to get its count or frequency. We can have the list of integer as a keys. So the first approach we think about this question is that we just sort this case by its frequency and get the top K one. So just do this way. We need to have the frequency largest as the first, and in a descending order. So we need to have the K2 in the front. Then we just iterate for K times. We know it's possible that the size is smaller than K, right? So we need to have some I smaller than K in this size, right? Return result. So this is our first approach, but this kind of approach is that we have a sorting for this kind of other case. The worst case is that every key, they are distinct, and this sorting will be n log n time complexity. So for this kind of, let's say, this kind of data range, 10 to the power fifth, this approach may be TRE. Sort by case, right? So we should have better solutions for this kind of way, better solutions to have better time complexities. So we say top K, we can use something like we want to have the top K maximal one. We can use something like a min heap. That is also very straightforward. We can use the priority queue, right? Priority queue. We can have it set to k plus 1. And we are going to have a B. We want to have a min heap, right? So maximum one, we need to have the min heap. Just every time we pop up pull out the minimum one from the min heap. So we iterate the key, right? In the key, in case min heap offer. So if I say if this key min heap first size equals k plus 1, we need to for the minimum. In this case, what's the in the heap will always be the top k maximum frequencies. And after we iterate, we just need to put the value to this result. We can get this out here because we always need this arrays. Yes, order does not matter. Priority queue has a type of error. You see, this kind of solution, it has runtime to be 53 milliseconds. So let's say for this kind of approach, use min heap to get to the max top k, right? Top k max. it will have the O n log k, right? Actually, log k plus 1, right? Time complexity. And the space complexity will be the items in a heap. It will be okay, right? So this is the second approach. We use priority queue. It will pass, but apparently it only beat 7.49 of the solutions. So means this time complexity may not be that good. We know for top K problems, one of the common solutions is that we can use quick select. We know quick select, we can partition those kind of arrays or list into two parts. One part will be a big part, and another part will be a smaller part, right? We can have some kind of criteria. For this kind of partition, we are partitioning a list, and we are going to partition based on the map. So I'm going to write this approach as well. I going to use a quick select. We're going to have a case, and we start from 0, and at the end will be case dot size -1. The end, right? And we are going to have the index is k plus -1. So we're going to have the third method. Let's write it a quick select. Here we are passing the list, and we have a start, and we have an end index, and we want partition to index. We can call it index, right? Because top K we are from the index 0 to k -1, right? So in this case, index 0 to k -1 will be partitioned, will be on the largest one, or from 0 to k -1. So write this kind of partition if start greater equal to end, return list get index. We're going to have a pivot and a rate equals list get start list and start. Okay, we need something to compare, right? To compare. So we need to pass in this map. All right. Int that equals start. Right equals end. While left smaller list. Right. While left smaller right. And map with we will get the key, right? The key, this is the index in this list. So it will be list get start. So because we are going to have the largest one on the left, so it's greater than map it. Pivot. Then we have left one list pivot. Sorry, this should be left. So it'll be right. If this is smaller than map it pivot, we'll have right, and we'll have this to, if left still smaller than right, we just will have the swap selection. Swap list left, right, and we can have left and right. And after we finish this while loop, the left pointer will be on the here, right? Will be one index to the right to the right pointer. So left will be here, and the right will be here, and this will be start. This will be end. So based on this kind of scenario, we're trying to see whether this k index is in this range or this range. So we write if index is smaller than right, we can say smaller equal to right. That's a return. Pick select list start right map index. And if index greater equal to left, we'll have a return. Pick product list left and map index, and going to return list get index. We haven't we after we do this kind of partition, we need to put that into the result array. So we'll have for int I equals 0, I smaller than k, I plus result I equals is it return result. You see, the time apparently is much faster than the previous solution because this one, it is a O(n) time complexity, right? And we just do the partition in this kind of case list. Of course, this one's space complexity is also a. So this is a third approach, that is using quick select. And for this question, we can have another approach that is called bucket sorting. So basically the idea is that we know for every key, it have the frequency. Those kind of frequency, it is can be 0, and the minimum of the frequency of the key is 0, and the maximum will be n minus 1 plus 1, right? N is this length, right? Maximum will be n, right? Maximum will be n, will be the length of the nonce. So if all of the elements are the same, the frequency is the n, right? So actually it is from 1, right? It doesn't matter. We can create buckets with n plus 1 length. And for each bucket, I'm going to have a list of integer to put those kind of keys into it. So for example, if a key, it appears 3 times, so I'm going to, for this key, it's A, right? Or number A. I'm going to put this A number into we get the buckets from list from the buckets index 3 and put the key into the list. And then after we create these buckets, we just iterate from the largest buckets. It has a highest frequency, and then trying to count to k with then we'll get the result. So let's write the code. I'm going to have int n equals nonce total length. And we're going to have buckets equals new. So we already have this count map, frequency map. We just need to iterate the keys. Key. We call keys. Let's say int count equals map. Right. So let's say if a bucket count equals null, we just create a new array list. And we are going to have buckets count and key. So in this case, we have the buckets, right? The highest frequency keys will be in the biggest buckets. Then we just iterate for each bucket, and also trying to see whether it reaches, for each for each list, and get the keys, and trying to count whether the keys has a number k. So we already have this here. We just need to write. We have a count. It's an index equals 0. Int I greater equal to 0. And also we know we this I we don't we know this index should smaller than k, right? And I minus because we want to have the result index to be the things we get from the list. So I say if bucket I equals none, we just continue. Then we'll have for j equals 0, j smaller than list equals brackets I back list size. The same thing is that we need to make sure the index should be smaller than k. J plus result equals J. And we return this result. You see, this time is also very fast because it's a bucket algorithm. The time complexity is also O(n), right? Because we just need to have n by m minus plus 1 buckets, and we just the worst case that is that we iterate the whole case. So that is just linear operations. Space that is also O(n).